Hello. Everything should be okay now. Do you hear me and see the desktop? Does that seem right?
Yes, Professor.
Okay, great. Thanks. Okay. Okay. Excuse me. All right. So, what I do today is keep on talking about language 8. Um, Let me download language 8. And uh, I'm it's a tricky language to describe. It's simple, but it's profound. So I'm really trying to come up with a good way to explain it to you. You know what's different, because I have a feeling that you've never seen uh, functional programming. My guess is that most of you have not seen functional programming. So saying that language 8 is a functional programming language probably doesn't really mean anything yet. So the question is, like, how to explain what's profound about language 8. Okay. Yeah, the tricky thing is to figure out how to explain what's really going on in language 8. You know, if you haven't seen some of the issues with functional programming before. Okay. Um, Now, I was thinking about it earlier today. The issue, there's two ideas that are in general important in programming that that are solved. One way to solve them is with closures, which is what language 8 has. Okay, one thing is higher order functions. There's this idea of higher order functions. And another idea in computer science is callback functions. Okay. Callback functions have existed for a long. If you Google callback functions, you'll find almost everything about JavaScript, because they become hugely important to JavaScript and web programming. But callback functions go back way before JavaScript. So here's a Wikipedia page about a callback function. Okay. Callback functions, higher order functions, they're becoming they're they're general ideas that are becoming really ubiquitous in computer science, especially callback functions. And closures are a way of making use of higher order functions and callback functions. Okay. So one way to talk about this, what's going on here, is what's a higher order function? What's a callback function? And why do you want closures? Because, for example, the C language doesn't have closures, but it has higher order functions and has callback functions. Okay, the C language callback functions go back to the 70s, and C makes lots of use of callback functions. C makes not a lot of use, but some use of higher order functions, a fair amount, but it doesn't have closures. But then closures turn out to be an elegant way to do higher order functions and callback functions. Okay, so it kind of comes down to being that closures, one way to think about closures is they're an elegant way to handle higher order functions and callback functions. Now, that's not the only reason for full closures to exist. There are other reasons for closures to exist. But when you're trying to explain them, I think this may be a good way to explain them, because this is what is mode. If you ask why does Java want closures, the answer is callback functions. That's a big part of it, is callback functions, and also higher order functions. But a big part of it is callback functions. Same with C++. If you look at why C++ programmers wanted closures, why the designers of the C++ language wanted closures, because closures can make working with callback functions a little bit easier. Okay, so okay, okay. I'm not sure how have you ever written code using higher order functions? Yeah, yeah. Is anybody actually, yeah, is anybody familiar with the idea of writing code using higher order functions, or know what they mean?
No, Professor, I
Yeah,
haven't. Mhm.
yeah. And what about callback functions? They're right now, callback functions are more common because they're ubiquitous in JavaScript. But if you haven't written a lot of JavaScript, especially if you haven't written many web applications, have any of you ever written code using a callback function?
No.
Bruno has. You have Bruno because we used them when we wrote the event handlers in the graphics class. The event handlers in the graphics class are examples of callback functions. We didn't really emphasize it that way, but event callback functions are event handler functions tend to be callback functions. So one big use of callback functions is event handler functions in Java. And this is almost every GUI does it this way. So Windows GUI, Java GUI, JavaScript, or OpenGL, almost any GUI system is going to use callback functions as event handlers. So event handler is a subset of callback functions. And again, you can write elegant event handlers if you use closures. Closures can make it easier and more elegant to write event handlers. Like if I understand closures and event handlers, understanding JavaScript closure with event handlers. Event handling in the closure library, JavaScript closure explained using events. See, people, one way to think about closures is, well, what it really comes to is closures are a way of doing callback functions, and event handlers are examples of callback functions. Okay. JavaScript, closure versus delegation, event listeners, delegation versus closures. Okay. Right. There's a lot written about this. This is very much on the cutting edge of of modern programming. Another way that this, another place where you see this a lot, not just event handlers, but callback functions and higher order functions, is what's referred to as asynchronous programming. What is callbacks, closures, promises, and async? Okay. Promises and async are a modern way of writing JavaScript programming, and it's related to callbacks and closures. Okay. And a huge amount of people are writing about this stuff right now. And some of the writing, like I haven't, some of the writing is good, and some of the writing is actually kind of not very well. Some of it's flat out wrong. Some of it's kind of goofy. It's kind of right and kind of wrong, and some of it's right. But there's a lot. You can see this stuff is written very recently. There's a lot of interest in this. Closures. See the words: callback, closure, promises, and async and await. Okay. There's all these ideas intertwined, and our language 8 can do all this. Language 8 can actually do all this. It can do closures and it can do callbacks, and language 7 can't. Well, language 7 can do callbacks but not closures. Okay, so like I said, higher order functions and callbacks by themselves don't need closures. Closures make them elegant. Same with event handlers. Event handlers don't need closures. Okay. Asynchronous programming doesn't need closures, but closures make all this stuff a little bit more elegant. Okay. So JavaScript has closures. So JavaScript has worked real well with callbacks and event handlers. Java didn't start out having closures, and C++ didn't have closures. And it made things a little bit less elegant. And the C++ and Java language thought that, if we give the language closures, it can make higher order functions and callbacks a little bit more elegant. Okay, so then a question is, like, how can we explain? Let's try to talk a little bit about higher order functions, callback functions. We're not going to talk about, well, maybe we'll event handling. Event handling is one use of callback functions. Asynchronous programming is another use of callback functions. Okay, so if you're trying to organize this in your head, callback functions are a very general idea in computer science. One way they get used a lot is in event handling in GUI programs. And another way callbacks get used a lot is in asynchronous programming, this thing called asynchronous programming, which has got to do with I/O. Asynchronous programming is a way of doing fast input-output operations. That's what JavaScript uses asynchronous programming for. When a web page needs to download 27 pictures, what a web page doesn't want to do, I mean, here's the example I show a lot, okay? Think about a web page like the Washington Post. There's a gazillion, see, notice how there's all these empty spaces where things are being downloaded. Did you know, if you notice that there were a bunch of empty places and then pictures filled them in, that's asynchronous programming. What happened was that the web page loads and leaves empty spaces for the pictures. And then asynchronously over time, all the pictures start filling in, but they all fill in at different points. Like one picture might fill in before another. That's asynchronous programming. They're not happening in synchronization with each other. The web page just loads and it fills in like now it's happening pretty fast, but when I first opened the page, you may have noticed that was blank and there was a blank there because the picture was, you're not gonna down there, like there's probably 50 pictures on this page, and you're not gonna load picture 1, then picture 2, then picture 3, then picture 4, then picture 5. That's too slow. You load them in parallel. So you essentially are loading picture 1 at the same time you're loading picture 2, at the same time you're loading picture 3, sometimes you're loading, but some pictures will load faster than others. So this is all done asynchronously. It's not easy to write this kind of code. It's tricky to write it because it would be a lot easier to just say load picture 1, then when it's done, load picture 2, then when it's done, load picture 3. That would be serial code or synchronous code, but that makes the page load way too slowly. So the modern JavaScript way is to load them all asynchronously. The way to do that is to make use of callback functions. Okay, essentially, there's a function that gets called when that picture is loaded. When that picture gets done loading, there's a function called to show it. There's another callback function that's waiting for this picture to load, and then when this picture loads, the function shows the picture. And then there's another call. Yeah. So every one of these pictures is shown by a callback function that'll get called when the picture's done loading. Okay. So there's asynchronous and callback going on. The asynchronous is that this picture's loading, unsynchronized with this picture loading, unsynchronized with this picture loading. They're all loading in the background at the same time. And then there's a function tied to each picture that will paint the picture on the screen when it's finished loading. So it gets called when it gets called back. You call back to the function when the picture is done loading. You call back to this function that draws the picture in the right place. Okay, and I don't know, like another website that's like this, the New York Times. These are the New York Times and the Washington Post. I know are examples of pages with huge numbers of, you kind of see that the page that, actually you see how much stuff is happening over time. Things happened not all at once, but things were like that picture loaded like a split second after everything around it loaded. Okay. Same with these pictures down here. There might be other websites you can load. You can think of other websites that are like this. If a website loads a huge number of pictures and maybe some videos and things like that, those will all be loaded asynchronously, so that you see an outline of the page first, and then you see things fill in over time. Things will fill in asynchronously over time. So asynchronous programming has become a huge part of JavaScript. Okay, yeah, and closures, what they really are is one technique for making this asynchronous programming a little bit more elegant. You don't need closures to do asynchronous programming, but they do make it nicer. Okay, so now let's talk about higher order functions. Then we'll talk a little bit about callback functions, and then we'll see like what they kind of have to do with what would be a closure. Okay, all right. So now if you go to language 8, there are some examples. Okay, a higher order function is a function that takes another function as an input parameter, or it returns a function. Okay, so I don't know if it was up to see. I mean, it says right here, a higher order function is a function that takes a function as an argument or returns a function. So either the return value is a function or one of the parameters is a function. Okay, in our language 8, we can write functions like that. Oh, actually, you can't write, well, let me download language 7. Language 7 can do higher order functions, but not in an interesting way. Okay, so I think I even have some examples in here of higher order functions in language 7, but it's not so interesting, but you can do it. Let's see if here's a higher order function. Okay, this is it's kind of a silly example. We talked about it a little while ago. What it does is f is the function that squares a number. G is the cubing function. So f is the squaring function, g is the cubing function. Then there's this function h, and it takes in a number. Okay, if the number, well, it takes in a Boolean. If the Boolean is true, it returns the squaring function. If the Boolean is false, it returns the cubing function. So h is a higher order function. It returns a function. Its input parameter is a Boolean, and it returns either the f or the g function. And the f and g functions are just these global functions. Okay, that's a trivial example, but it's a higher order function, and you can do this in C. It's essentially just returning a pointer to that function or a pointer to that function. Okay, so it's not very deep, but it is a higher order function. So the function it returns a function value. Then down here, I call h with true. Okay, so this evaluates to the squaring function. And then I'm applying the return value of the h to 5. So I'm squaring 5 to get 25. So R1 will be 25. Okay. On the other hand, here I call h with the parameter false. So h returns the cubing function. So here's the cubing function applied to 5, returns 125. Okay, kind of a silly, but it shows that higher order functions can exist in a simple language. Okay, so this language has higher order functions. Now, the reason that's kind of weird is if you go to the internet and you like this thing here, when I Googled higher order functions, this first result I got, this is a pretty famous book. This is a book that's a real interesting book on how to do functional programming in JavaScript. Okay, it's kind of an interesting, pretty well written book on how to do functional programming in JavaScript. The name of the book is Composing Software. It's a very sophisticated book, yeah, but it makes you think that higher order functions are part of super sophisticated functional programming. And what we just saw a minute ago is that higher order functions are trivial. Yeah, a function that returns a function can be written in almost any language in a trivial way. Okay, so this is a trivial example of a higher order function, but at least it is technically a higher order function. Eventually you want to see how higher order functions become very sophisticated. That's what he's talking about here. He's talking about really interesting higher order functions. But the really interesting higher order functions almost always need closures. That's kind of what we want to get at. Interesting higher order functions need closures. Okay, but higher order functions by themselves, that idea alone, no, it doesn't need closure. You can do it, you can just return a pointer to a function. So you can do this in C. I could write this function in C real easily. I think I did it too some point. I don't know if we did it in class, but I know I wrote it. I at some point I wrote that function in C just to show that it was it's messy in C because you have to work with function pointers. You're writing a function. This H would be a function that returns a function pointer. We didn't do that in class, did we? Because I know I wrote it. I may have written it and then not used it in class. I'm trying to remember. I remember writing it because I was, oh, I think it's right. Yeah, I think it's right here. Yes. Yeah, there it is. This is standard C. There's the squaring function. There's the cubing function. There's the function that takes in a number. If the number is less than 0, it returns the squaring. If the number is greater than 0, it returns cubing. And this is the bizarre, impossible to read way you say in C that the function CH is returning a pointer to a function that takes in an int and returns an int. This is impossible to read. It's impossible to read, but the name of the function ch for choose, it takes in int z, it returns a pointer to a function that takes in an int and returns an int. Okay, impossible to read. There's a little there's a pointer up here to help pages to try to explain this. Returning function pointer types. Okay, so this is the C version of H. Okay, there's written in our language, there's written in C. Notice it's just one line. It's a short line of C. That line of C is that line of language 7. Okay, they're the same thing. And then this main method pretty much does what this thing down here does. Okay, so language, so C language has has higher order functions. The C language can have a function that returns functions, and it's got an ugly notation for it. It's got a very hard. It's one of the biggest problems with C is its terrible notation for function pointers. Okay, and if you read these two links up here, they point that out that that it's very hard to work with this notation. Okay, it's very hard to read these signatures that are function pointer to function declaration. Yeah, how to read a pointer to a function. Okay. Okay. So C can do so. Now that's one kind of first class function. That's a first class function that returns a function. The other kind of higher order function. There's two kinds of higher order functions. If you go back to that guy's definition of a higher order function that takes a function as an argument or returns a function. Okay, so we just saw in language 7 and in C, it's not that hard to return a function. Okay, in a kind of a trivial way, but you can have a function that returns a function. What about a function that takes an argument? Okay, I think that the same, I think there's in here too. I thought I had one, let's see. No, I didn't actually write an example where the arguments, let's see, maybe it's in the other file. No, I forgot to write an example where the arguments are functions. Okay, it's real easy to do that. Can modify one of these. Okay, I'll write one real quick. It doesn't take much to do it. Okay, just make a slight change to H. Right now, H is returning a function. So here, I'll write it this way. So I want a function H that takes in 3 parameters, an X. Okay, so it's lambda. Okay, I'll have it taken in X, an F. Well, I'll call it F1, F2. Okay, so it's a function. It's going to take in a number or a Boolean and a function 1 and a function 2. And then it's just going to, and it's going to do essentially what H did, but instead of saying if X returned F, else return G, it's going to say if X call F or call G. Okay. So on, then I need another parameter on Y. Okay. So watch this. So then now it'll say, the next line of code will be if X, oops, if X, okay, if X, I want to apply F to Y. Otherwise, I want to apply F2 to Y. So it's supposed to be F1. Okay, so here's, this is going to be a real simple example. The function H takes in a Boolean that chooses between F1 or F2 and a parameter Y to plug in to F1 or F2. Then if the Boolean is true, so actually make this easier to read, make that B for Boolean. Okay. If the Boolean is true, apply F1 to X to Y. If the Boolean is false, apply F2 to Y. Okay. Then that closes the apply, that closes the if, and that closes the lambda, and that closes the definition of H. Okay. And then I want to just call it. Okay. So I'll say there R1 is going to be return value from applying H to true 5 F and G. Okay, so what's that going to do? That's going to apply H, the parameter true, which means we're going to pick F, and we're going to call F with parameter 5. So that'll give us 5 squared. And then the next line would be to do the opposite one. need to add these little pluses. Okay. In this case, I want to false. Okay. All right. And say, so let's see, that closes that line of code. Let's see, there, apply. Need one more close parentheses there. Close the var, close the apply. No, see, no, just two. Close the var, close the apply, close the var, close the apply, and then close the program. Okay. Okay, there should be, there's a program, we'll run it in a second, make sure it works, okay? There's a language 7 example, there's a function, h, it's a higher order function. It takes in function parameters, and then it'll call, notice it's not much different than the function that chose whether to return F1 or return F2. Now it's just gonna call F1 or call F2, okay? And I'm using the squaring function and the cubing function as the parameters, okay? Now let's see, this should compile. If I got all the parentheses balanced, I probably didn't. Oh, I don't need a comma there. Okay, and then we see if it runs. If I got the, okay. Oh, see, I got a runtime error. What I do? I used R1, R1, so that should have been an R2 there, okay? See, I had a runtime error. I had a redeclared variable, okay? So compile it again, run it, okay? Now let's see if this makes sense. Did we get the right kind of output? Okay, first of all, look at the function in C notation. F of x is the squaring function, g of x is the cubing function, h takes in a Boolean, a number, and two function parameters. If B, call F1, else call F2. So it's a higher order function because its arguments are functions, okay? And then here I call H with true, here I call H with false. I should get back 25 and 125, okay? And then you go through the execution. F gets put in the global environment, then G gets put in the global environment, then H gets put in the global environment. That's just F is evaluated and stored in the global environment. G is stored in the global environment. H is stored in the global environment. So F, G, and H are stored in the global environment. Then we get to calling H. Okay, so here's where we call H with a, so there's the function activation record. We called H with the B being true, with Y 5, with F1 essentially pointing at the squaring function, and F2 pointing at the cubing function. So there's the function parameters. So that's the higher order function. Its parameters are functions. In C, these would be pointers to functions. In this language, they literally are the functions themselves. The function values point to these trees in the abstract syntax tree. So this parameter here, F1, is actually pointing at the abstract syntax tree for that function. And this parameter, F2, is pointing at the abstract syntax tree for that function. Whereas in C, F1 would be a pointer to the memory address of where this code is stored, and F2 would be the address in memory of where that code is stored, which is actually essentially what a function, when we have a Java reference to that abstract syntax tree, it really just is an address in memory of where that abstract syntax tree is stored. When this thing we say is a reference to that abstract syntax tree, it really just amounts to it's exactly an address in memory where that abstract syntax tree is stored. So they essentially are pointers, okay? So we call H with the Boolean, the Y, the Boolean is true, Y, and then it's gonna give us back a result Okay. Oh, here's then it calls. See, now notice that we gave it the Boolean true, so we know it calls F1. So then here's the calling of that parameter. See, here's calling the well, you can't tell who, actually, you can't tell who's being called. It's a function activation record. It's calling the thing that got called. So we can't quite tell if it's F or G being called because we don't see the name of what's being called. But there's the calling of the function. Then there's the storing of the return value, 25. Okay, so this function gets called and it's going to return 25. Then we're going to call it again. We're going to call H again. Notice that this time we call H with false is the parameter. So we call H with false. That's going to choose F2. So then H calls F2. That's this activation record. This is the activation record of H calling F2. Okay, that's this last activation here. Okay, and it's going to return 125. Okay, so there's the return value, 125. Okay, so we've run a so there's a higher order function in language 7 that takes function parameters. And I wrote this in C. Oh, it's one of these in C. Let me see which one it is. It's this one here. No. Demo 4. It's this one. Here's a function that takes 2 function parameters. Again, it's not easy to read. Okay, so here's the squaring function. Here's the cubing function. Here's the function that it takes in a number Z and it takes in well, actually, what this one does is this is going to take in 2 functions as parameters and return one of them. So this is not quite the example we wrote, but this is a higher order function that takes a function as parameters and return value. So this does both. This is an example in C of function parameters and function return value. See, it's going to return either F1 or F2. So the signature of the function is a mess to read. CH is a function that takes in an int Z, a function pointer to a function that takes in an int and returns an int, and a pointer to a function that takes in an int and returns an int. And CH returns a pointer to a function that returns an int and take. So notice that this thing here is the return value of this guy here. No, I'm sorry. Well, this guy here is the return value of the function that this guy points at in its return value. This guy returns a pointer to a function that returns an int and takes in an int. Believe me, these are the most unreadable things in programming. C function pointers are crazy. Okay, they're just really strange. Yeah, of all the things in C, C is a very elegant language. It's got a lot of nice features. You know, of course, it's probably the single most used language ever. Okay, but the trouble is, it's got this one real bad weakness of function pointers. Function pointers are they accidentally stumbled into probably the worst notation possible for function pointers. Okay, All right, so there's a function that takes, there's a higher order function that takes function parameters and returns a function, okay? So you can see, we can do it in our language, you know, we can do it in our baby language. Where was it? Okay, here's our baby language, language 7, a higher order function that takes function parameters. And we just a minute ago, we did a higher order function that does function return values, okay? And you can do it in C, but here we're doing higher order functions in a, you know, it's really kind of simple. The key is that the functions themselves are globally defined. Notice that that's true in the C case too. In language 7, remember, you only have globally defined functions. Same with C. In C, all the functions appear at the beginning of your program. See, all the functions are global. So if this function takes in function parameters, the parameters have to be these other global functions. So when I call ch, I can pass it sq or cb, you know, the squaring function or the cubing function, and it can return. So the only functions I can pass around are these global functions. Okay, that's what makes higher order functions of well, simplistic. I shouldn't say of limited use. They're very tremendously. I'll show you in a little while how they get used a lot in C. I mean, they're the basis for all the callbacks in OpenGL. So, for example, OpenGL, the 3D graphics language, is written in C, and all the GUI stuff in OpenGL, all the callbacks are in C, you know, using these higher order function stuff. Okay, and there's lots of other examples of higher order functions like these in C, but the higher order, the function parameters are all globally defined functions. There's only globally defined functions in the language. And that's what language 7 is. If we go back to language 7 and we look at its syntax, that was clear in the syntax that functions can only be defined at the top level in a prog statement. See, function only appears there at the beginning of a program. Before you get to the main body of the program, you have all the function declarations first, then the body of the program. Just like C, all the function declarations first, then you can have main. And you have to have the function declarations before main. If you can't reverse the order. Well, you can reverse the order, but then you have to use function prototypes. So you can reverse the order, but you have to have the function prototypes in front of main. So either you have the function definitions coming first, or you have the function prototypes coming first. So all the functions have to be defined first before you can use them. Okay, same in language 7. The functions are all going to be here. This is a sequence of function definitions, then the body of the program, essentially the main expression. We don't have a main function, we have a main expression in this language. Okay, all right. So first class functions are functions that take functions as parameters or functions that return functions. Okay, and here we've seen baby examples of first class functions. They don't make it look like they're useful, but they're just kind of baby examples. To make them useful, you have to do some GUI programming and then see how your event handlers and your GUI programming is all based on callback functions, which are essentially versions of these first class functions. Okay, well, I think we'll see if we can explain those later. We'll try to give you a sense of what we mean by callback functions, how they get used. But callback functions are examples of these kind of baby first class functions. Okay. Okay. Now, well, actually, let's see. Okay, over here, I was saying that remember we said the point of closures was to either have to make higher order functions or callback functions work better. Okay. Higher order functions and callback functions aren't the same thing. You can have callback functions without having higher order functions. You can have higher order functions without callback functions, though it turns out a lot of times they're intertwined. You know, they do get kind of intertwined, but they actually by themselves are different ideas. Higher order function is real specific. Higher order function means you have a function whose parameter is a function or its return value is a function. Callback function is a little bit harder to define. There is no real precise definition of what a callback function is. Okay. I mean, I can give you a kind of a vague sense of what a callback function is. Let me think. In a way, a better name for callback function would be stored function. Let me show you what I mean by that. Let me write another language 7 example. Let me write a simple language 7 example. Actually, this is a tedious way to write code. Language 7 lets us write, for example, this example here. Let me show you. I can make this much easier to work with. Whoops. You don't have to write the code like this. I can just create a file like that. Strip out all this kind of stuff here. And make a language 7 file, just like you would in any other programming language. Okay, there's a language 7 file. Okay, and I can save it as higher order function dot language 7. I'll use language 7 as the extension. So there's my higher order function example, language 7. So I save it as a file. Then I can run it in the interpreter. Okay, so I can go, I saved it in this folder here. There it is. Open a command prompt to this folder. And remember, the way it's designed, this CMD file, if you double click it, it runs the interpreter as a REPL. Okay, it runs the language 7 interpreter as a REPL. On the other hand, you can run the language 7 interpreter at the command line by saying language 7.cmd, then the name of the program to run higher order function, and it runs the program. Okay, so there's the 25. So it ran the it gives you the code. It dumps the source code to the standard out, so you can see what program it's running, and then it runs the program with a lot of debugging information. And if you don't want all that debugging information, remember, you can go back and recompile. You can rebuild this jar. Right now, this is the program that is the REPL, and it's got the debugging set to 1. If you don't want the debugging set to 1, you can set it to 0 and then rebuild the, like you just do that. Build all the classes. Build the jar file. Now you can clean up. Now this jar file is going to run the program. Now if I rerun it, see, it's a lot cleaner output. Now it dumps the source code and it just gives you the result. So all that debugging information went away. So you can run it either way. You can run your programs with all the debugging information, or you can run them without the debugging information. Okay. All right. And the result was, now this only shows you the final result. Whereas over here, when you see that's what the nice thing about this is you see what's inside the global environment. So R1 wasn't a return value. It was just a value from the intermediate. It was an intermediate value, but we could see that it was 25. And R2 was another intermediate value, but R2 actually ends up being the final result. Remember, when you run a program, the final result is the last expression evaluated. Okay, that's true of most functional programming languages. They work that way. That the default return value is whatever's the last thing you calculate. That's the actual return value. Okay, so you can run the program either way. Okay, so now if I want to write, now I want to show you an example using a callback. Okay, now I'm going to go back and rebuild that with the debugging, because the debugging actually does make it more useful. So it's just real simple, just build all the classes, build the jar file, clean up. Okay. Notice I don't need Maven or Gradle or all these. This is one thing that I kind of try to emphasize. Out in the real world, people tend to use huge tools to get even little things done. There's something called there's something called Maven, there's something called Gradle, and there's something called what's the other one? No, I'm drawing a blank. The other Java build system. I can't remember the name of it, but there's several different Java build systems. They're really useful if you're building programs with thousands of files or even hundreds of files. But when you've got something small like this, Gradle is just a huge nightmare to use on a small project like this. So is Maven. It's much nicer to just write 2 or 3 little batch files to do just what you need done. You don't need to use a sledgehammer on a small job. So this is an example of a small job that doesn't need a sledgehammer. So these little build scripts are so much easier to use and so much more portable than having something like a Maven project or a Gradle project, or even, for that matter, an Eclipse project or a NetBeans project. See, these are just 3. Each one of those is just a 2 or 3 line batch file, and they do everything we need. And it's really easy. They can be translated into script bash files too. I mean, if you want to turn that thing into a bash file, all you do is delete the pause and change the name from CMD to SH. The syntax in here is exactly the same for bash or for CMD. So these things, they trivially convert from being CMD files to being bash files. Okay, now we just did this higher order function one. Let's do a callback one. Okay, let's do something that is kind of like a callback function. Okay, so create a, I'll call it callback dot language 7. Something like a call. I'll do an example. It's something like a callback function. Okay. Okay. Here's what I'm going to do. I'm going to create a variable called callback, and I'm going to temporarily put 0 in it. But I really mean that variable to let's see. Yeah. No, actually, I don't know if I can do this in this language. Let's see. Let's see if we can do. I'm not sure if this is going to work. Okay. And then I'm going to define a function called register. Okay. That takes, it's a lambda, and it takes in a parameter f. It takes in a function, and all it does is it sets callback to f. Okay. In the world of callback functions, you always have this something that's the register function, which registers a function as the callback function. So what I want to do is I want the register function to be the thing that takes in a parameter, which is a function, and then it sets the callback function to be that parameter. Okay, right? Now notice that that makes register a higher order function because register takes in f as a parameter. Okay, so in a sense, I still have a higher order function here because that's a function as a parameter to register, and register is going to set this thing to be that function. Okay, now let's see, do I have enough parentheses? Okay, and then I could apply the callback function to say, oh, but no, first I have to, well, I need something to register. So now function, squaring function, back, write the squaring function. Squaring function is okay, define the cubing function. Okay, now I got two functions I could possibly register as callback functions. So apply, call the register function, and let's register the squaring function as the callback function. Okay, and then I can call the callback. I can apply the callback function to say 5. Okay, and that's the end of the program. Well, actually, what I'll do, I'll make this there R1. That's my first result. And then I can change I'll change what's registered as a callback function. I'll apply register to the cubing function. So I'm changing who's registered as the callback function. And then call the callback function again. And store the result in R2. More in almost every situation where there are callback functions, this is more or less what's happening. There's somewhere a table of callback functions that remembers what you've registered as a callback functions. That's why I say that callback functions are probably better thought of as stored functions. So here I'm just storing one callback function, but usually in a real environment, there'd be a table of these things. There would be a table somewhere that stores all the callback functions. And every time you register a callback function, it gets added to the table. Okay. Okay. So and then you could register callback functions for different purposes. Like you'd register a mouse click callback function, and you'd register a keyboard callback function. So you'd register callback functions for different purposes. Okay. Right. And then later on, someone's going to call whatever you've registered as the callback function. See, that way you have a name for this. What it is notice it gives you a way of saying that I have a standard name for what I want done. So instead of saying call the squaring function or call the cubing function, I say call the callback function, where the callback function has been determined ahead of time to be the right thing. It's sort of just a level of indirection. It's really not a deep idea. The idea is that I want you to choose what to call when I call callback. Or another way to think of it is, I want you to choose what to call when a mouse is clicked. When somebody clicks the mouse, you get to decide what gets done. So you register a function that is going to be called when a mouse gets clicked. So you could call, this would be the mouse handler. Then it would be, these callback functions would be like mouse handler. Like I could have two callback functions up here. I would have mouse handler and key handler. And then I'd have a register mouse function that would set the mouse handler, and I'd have a register key function that would set the key handler. And they're just stored. It's going to store. Yeah, I could actually make it like that. So mouse handler, key handler, register mouse, register key. This would set the mouse handler to F, and this would set the key handler to F. They're callback functions. And then down here I could call the key handler, or I could call the mouse handler. Okay, and I could register the squaring function as the mouse handler, and I could register the cubing function. Okay, I mean this is actually this is amazingly close to what's really going on in a GUI system. Somewhere there's a table of event handlers that it's hidden from you, but it's there somewhere. You're given these functions that you call register mouse handler, register key handler. And all it does is it takes your function as a parameter and stores it in the table. And it takes your function that you want to register and stores it in this table. Okay. So now now the system, when it gets a mouse click, calls mouse handler, which is whatever, now it's whatever you decide it's going to be. And when it gets a key click, it calls key handler. Okay. So you register mouse handler to squaring, register key handler as cubing. When a key event happens, you call the right function. When a mouse event happens, you call the right function. Okay, so this is actually surprisingly like what's really going on. What the only difference is, instead of having a couple variables up here called mouse handler and key handler, the GUI system would have a table somewhere buried in the libraries that keeps track of whatever you've registered as the mouse handler and what you register as the key handler. Then when somebody clicks the mouse, the GUI system calls your mouse handler. Well, you call these, you register your event handlers. The GUI system calls your event handlers. But it has to know, but see, the thing is that the GUI system isn't going to know you want to call something called square or cube. That's why it needs to kind of like say, you tell us what function to call, we'll store it in a variable, and then we'll call that variable. So the GUI system says, oh, when a key click happens, I call the key handler, whatever is registered in key handler. When a mouse click happens, I call whatever is stored in mouse handler. And you get to decide what's stored in mouse handler and what's stored in key handler. So you register your event handler, and then the GUI system calls your event handler. And this is the typical, this is the design pattern of GUI systems. This is the design pattern of event handlers. Okay. Now, right now there is a higher order function in here. The register function is an example of a higher order function, though. I could get away. I could eliminate it by just telling you where to store your mouse handler and where to store your key handler. So I could essentially get rid of the higher order function by just doing the following. Instead of registering the mouse, you would just say set mouse handler to square. And you would say set key handler to cube. And then you don't need these two register functions. If they told you exactly where to store your mouse handler function and where to store your key handler function, you wouldn't need the higher order function. So you would register your event handler just by storing the name of your function in that global variable and the name of your other handler in that global variable. So I don't really need this higher order function here. I can still get this idea this way. Okay. Now, these are actually two different functions. Let me I'm going to save this one as a different name. I'll call it callback 2. Okay, this one's like it really is. There's almost always a register function that you call to register what your callback ham should be. Okay, and they call them callback functions because the system calls back to your function. The idea is that the system. Here's another way to think about it. There's an old saying, "Don't call us, we'll call you." This is exactly that pattern. Sometimes this is called the "don't call us, we'll call you" design pattern. I never call this function. And in a GUI system, I never call my mouse handler. I write my mouse handler, I never call it, because it's only going to be called by the GUI system when somebody clicks the mouse. I never end up calling my mouse handler, they call it. So that's called a callback. Because I don't call it, they call it. So some people kind of coined the term, it's a callback function, because you write the function. There's my handler function. Okay, I never call my event handlers. I never call them. They're going to be called by somebody else. I register my event handlers, but I never call them. And then when they're called indirectly by the name of whatever the GUI system calls them. So the key handler is now just another name for square, and mouse handler, or the other way around. Key handler is just another name for cube, and mouse handler is just another name for square. Okay. Right. Now, actually, I'm not sure if this is going to work. I'm not sure if I think this will work. Let's see. I think it'll work. Okay. So how would I check? I can go and run it now. So open a command prompt. Language 7 command on, what does that call it? Callback. Okay. Now notice it blew up. I got bad function value, apply mouse handler to square. Oh, did I? Let's see. Oh, I used the wrong name. I wasn't, you apply register mouse to square and register key to handler. I wasn't thinking when I wrote those. Yeah. So you call register mouse to register square as the mouse event handler, and you call register key to register cube as the keyboard event handler. So register mouse and register key set the callback functions. Okay. So I had the names misspelled there. Okay. Let's see if this works better. Okay. Yeah. See, now there's the results. When you apply the key handler to 5, you get back 125. And when you apply the mouse handler to 5, you get back 25. Okay, so it worked. Yeah. Okay, so these are callback functions. Okay, this is the idea of a callback function, and then I could do it without even the higher order function if I do callback to, if I didn't do anything. Let's see. I probably got something goofed up in this one. No such file. Callback. Did I misspell something? Oh, it's callback dot. Let's see. Yeah. I've got the dot in the wrong place. Okay. There. See, same result. Okay. I don't, callbacks don't really need the notion of higher order functions, though they're usually written using the register function is always a higher order function. It's a simple example of a higher order function. It takes in a function and it just sets the handler to be that function. And it takes in a function and sets the key handler to be that function. Okay, so it's not a very deep higher order function. So you could just set these things directly yourself if you know where to store them. Okay, so you don't need a higher order function. So a callback function is nothing but a stored function. Now it turns out storing functions is a deep idea. There's actually a word for all of this. We've been talking about higher order functions and callback functions. I think a better name for callback functions is stored functions. This falls under the term first class functions. See, a first class function is a function that you can use as a value, as you can give it, you can pass it as a parameter. It's essentially saying you could do all these things. A first class function is a function that could be a return value, it could be a parameter, or it can be stored in a variable. Okay. Programming language is said to have first class if it treats functions as first class citizens. Language with first class citizens, names of functions don't have any special status. They are treated as ordinary variables. What it really means is they can be, see, it should say that you can store them in variables and you can pass them as parameters and you can return them as functions. So all the things we just did, the function that takes a function as parameter, the function that returns a function as a return value, and storing functions in variables, all of those really boil down to what we mean as first class functions. Okay. Language 7 and C have first class functions. Closures will end up making first class functions more usable. Now, a lot of times first class functions are thought of as being completely intertwined with what are called closures. But what we've just seen is that first class functions we've just done first class functions in language 7, but we're going to see on Wednesday, we'll come back to this, that if you add closures to first class functions, you get very elegant programs. You can write better programs when you combine first class functions with closures. Okay, so that's what we're really getting at. Combine first class functions with closures. And then first class functions means either higher order functions, functions as parameters, return values, or functions as input parameters, or first class functions can be these stored functions, which people tend to call them callback functions. I really always thought that it would have been better if they called them stored functions, because it really just means you've asked the system to store your function somewhere so that it can call it for you later on. So when you register a callback function, you're saying, remember this for me. Remember it somewhere. Store my function, store a reference to my function so that you can call it later on. So a better name for callback functions would have been stored functions. And stored functions and higher order functions are all examples of first class functions. Notice that computer scientists have all these names, and the idea is to try to get used to these names. Callback functions, higher order functions, first class functions. right now we're seeing that those actually are all kind of the same thing. Higher order functions and callback functions are examples of first class functions. Okay. Closures are related to these, and there's a lot of misconception out there. Sometimes people will tell you closures are first class functions. That's not true. Closures are related to first class functions, but you can have first class functions without closures. Okay. So you'll see all kinds of misrepresentations of some of these things. But first, what it boils down to is first class functions are a simple idea. Closures make them more elegant. When you combine closures with first class functions, you get very elegant design patterns, which make callback functions more useful. They make asynchronous programming work better. Okay, they make higher order functions more useful. So all these things become more useful when you combine them with closures. Okay, so that's trying to get at what the key idea here is. Okay, now I'll try to put up on the website all like these C examples. I probably forgot to show them to you before because they were actually written some time ago, and I don't think we went over them in class. I don't remember if we did or not, but they actually were from March 3rd. But I don't think I used them in class. They're up on the website. In fact, oh, if you go over here. Oh, they're not up there. Oh, I really did I didn't even put them up there. Yeah, I must be one of those days where I was just so busy. I completely, that's why you don't know. Yeah, I didn't even put that folder up there on the web. The folder from March 3rd, I never put it up there. Yeah, so I'll put this up there, and then on Wednesday we'll talk a little bit more about these examples because these are the examples in language 7 that motivate the whole point of language 8. Okay, so I'm not sure why I forgot to even put these up on the website. Okay, so but what we want to do is take all these examples and then make them nicer in language 8. With language 8's closures, we can make these things all kind of nicer. So we'll do these examples. We'll say more about these examples on Wednesday. I'll put them up on the course website. I'll make sure they're up there, and then we can, it's kind of nice to see how they can be done in C at the, so there's the C version, the language 7 version, C version, language 7 version. So we'll compare them a little bit more on Wednesday, and then we'll see how to rewrite them in language 8 more elegantly and see what modern functional programmers are like about their language. What makes them so proud of their functional programming languages. Okay, so we're running out of time. So anybody got any question?
I have a quick question.
Mm-hmm.
So we have 4 tags total right now, right?
Yeah, uh-huh.
Okay.
Right.
Just making sure.
Well, there were 3 tags, Boolean and integer, and then functions, lambdas, and now
Right.
you're adding the array one, right?
Yep.
You're adding the 4th tag.
Okay.
Yeah. So you have to add that tag to the list of tags in the value folder.
Right.
And you have to add a little bit of code for it. But yeah, that's part of the assignment for you to define that tag.
Got it. Thank you.
Okay. All right. So I'll go ahead and stop sharing, and we'll meet again on Wednesday, and we'll keep talking a little bit about these ideas of higher order functions, first class functions, and why closures make higher order functions and first class functions and all this a little bit better. Okay. All right. So see you on Wednesday. Bye.